Hello everyone, welcome to my channel Euclid Mathematics. In my today's video, we are going to learn some of the examples from CSIR net. You can check my videos from playlist. So there I explain some of the concept along with the examples. Okay. So in my today's video, I will explain previous year question from CSIR net which asked for 3 marks, which is June 2019. It is a single selective question. Okay. So we have to check whether which one of the option is correct. Okay. So let's read our question. So f n x is given x raised to 1 by n and x belongs to closed 0 1. That interval is more important. Okay, and then we have to figure it out which one of the option is correct between these options. Okay, first option it says that limit n tends to infinity f n x exists for all x belongs to closed 0 1. Okay, for that interval limit n tends to infinity f n x exists. Okay, now next option it says that limit n tends to infinity f n x defines a continuous function on closed 0 1. Okay, so for checking continuous function, we have to check whether the limit of function at end point it is 0 and 1, which is exist or not. If the limit exists for end point, that means the limit between the all points 0 and 1, between all of the points are there, our function has finite limit. Okay, and which gives a continuous function. If function is continuous, then we have to check it is for the converges uniformly or not. Okay, so if fn is converges uniformly, then C option say that fn converges to uniformly on closed 0 1. So here one short trick. If function is not continuous, that means it is not uniformly convergent. Okay, converges not uniformly. So if we have to check here whether it is continuous, then we have to check for convergence of uniformness. Okay, uniformly convergence. If it is not continuous, then we do not have to go for option C. It is obviously not uniformly convergent. Okay, and now option fourth D option it says that limit n tends to infinity f n x is a 0 for all x belongs to closed 0 1. Okay, so we have to check it for the n tends to infinity of nx. Now let's get started our solution. Okay, so in my solution we see it here. We have to check f nx as the exist or not for all x belongs to closed 0 1. Okay, so we can see it here. F nx given in example x raised to 1 by n and x is from closed 0 1. Okay, so go for the next. We have to check whether limit n tends to infinity f nx exist or not. Okay, so apply limit n tends to infinity, then we will get the first option which is correct or not. Okay, so we are trying to eliminate the option because in example we cannot say which one of the option is correct. Okay, might be there are some other way of thinking also. Sometimes we cannot get the correct answer, so it is better way to eliminate the options. Okay, so you can see it here. After applying limit n tends to infinity f n x, okay, which is a x raised to 1 by n, and n tends to infinity x raised to 1 upon infinity, it is goes to 0. Okay, 1 upon infinity is a 0, so x raised to 0 is a 1. Okay, so that means limit n tends to infinity f n x, which gives the value of 1, which is a finite and exists for all x belongs to closed 0 1. Okay, that means it is limit exist and finite. Now go for the other endpoint. Okay, other endpoint, that means we have to check out the check it for 0 and 1. Okay, so whether the function is continuous or not. So I got it here, my first value which is a 1, and our first option it says that limit n tends to infinity f n x exists for all x belongs to 0 1. Okay, that means the value for f n x it gives 1. Okay, so it is finite and exists, so our first option is a true. So it is a single selective question. So that means our first option is true. That means obviously remaining wrong. Okay, but let's check how remaining option is wrong. Okay, now we have to check whether the function is continuous or not. Okay, so we have to check only the limit of a end point for our function. So limit n tends to infinity f n x is the limit n tends to infinity x raised to 1 by n. Okay, okay, so when we apply limit n tends to infinity, it gives 1. Okay, now let's check for the continuity of a function. Okay, so continuity of a function, it says that we have to check limit of a end point for our f n x. Okay, so when x is 0, limit n tends to infinity f n x, it goes to 0. Obviously it goes to 0 because x f n x it is here x raised to 1 by n, and x 0 is a directly function goes to 0. And when x tends to 1, okay, x goes to 1, then x raised to any power 1 raised to any power, it goes to 1. So we can see it here. Okay, the value for end point of a limit which comes different 0 and 1. Okay, so when x is 0, then f n x goes to 0, f x goes to 0, and when x between 0 and 1, we get the value 0. That means limit exists, but at different endpoint it gives different values. Okay, and it violates the definition for continuity. Okay, so we can see that a function which is not continuous because it has two different values. And if function is not continuous, then the function it is not uniformly convergent also. Okay, now let's check out the option, which one of the option is correct and wrong. Okay, so as we see that our first option is correct here, limit exists for all the points. So next gives define continuous function. It define a continuous function, but it is not continuous function. It gives two different value for two endpoints. If it is not continuous, then it is not uniformly convergent. Okay, so we do not have to check it here. So or you can check it by other tests also. Okay, there we learn Yemen test, for uniformly convergent, Weierstrass test, ABEL'S test, Dirichlet test. You can apply which one you found it comfortable to apply there. Okay, so use it. And fourth option is given, limit n tends to infinity, fnx is 0. Okay, if that question is multiple answer, then it is a true. Okay, but it is a single answer. We got the fnx is a 0 and it is also 1. Not only 0, it is also 1. Okay, so that's why we cannot say option D. Okay, we cannot say whether option D is correct or not, because we got the option answer 0 and 1. Okay, when n tends to infinity in that interval. Okay, so option D we cannot say about it. So our option first is true here. Okay, so I hope so you all have understood my today's lecture on a previous year question from CSIR net. Okay, so thank you everyone. Thank you for my today's lecture.